impossible, there were people who said, no, they're not. And it wasn't just scientists. There were engineers and managers who said, we want to make this happen. It's sort of what we do at NASA. Everything that we do at NASA was impossible not so very long ago. And so, anyway, that's what I wanted to do, was to give thanks as what we have today is an unveiling of a medal, actually a replica, not the real one, which is safely stashed away. But I have a few charts to sort of remind us of what it was that we tackled and who the people were, because indeed it was a huge team effort. It was a family effort, practically. It lasted forever, practically. But that actually now seems like a relatively short project compared to some others. So now I'd like to show you some of our charts that remind us of the history of the project and what it was that we accomplished. So let's look at our next chart. This is what the Royal Swedish Academy said about what they were giving us a prize for this discovery of the black-body form and anisotropy of the cosmic microwave background radiation. I will explain what that means. The black-body form, we have a curve, and the anisotropy is Greek, and it means not the same in every direction. So now I need to show you why it was so important to people. So on our next chart, we have a picture of me. That's me right here in this room here on October 3, 2006. I believe we had our first press conference to explain to the world what this was all about. And I must say that was the first experience I had of paparazzi, because here I was in front of a table and there were about 12 cameras aimed at me and they were going boop, boop, boop. So it was popping. Then on December 10th, that's me with the King of Sweden receiving my diploma and the medal, and trying to remember who to bow to first. So it was all carefully rehearsed. Our next chart tells you a little bit about how we got where we are. 1974, only 5 years after our first Apollo landing on the moon, NASA said, what are we going to do for science? And called for Explorer satellite proposals to be sent in. And so unexpectedly, I think for NASA, there were over 150 that were sent in for Delta rocket and Scout rocket launches. And there were 3, as it turned out, on the cosmic microwave background radiation, which was itself only recently discovered in 1965. So there was one from Jet Propulsion Lab, one from Berkeley, and one from the team that we started up at NASA Goddard. I was a young postdoc at the Goddard Institute for Space Studies in New York City. And so I said, well, Pat Thaddeus was my postdoctoral advisor, and I said, you know, my thesis project didn't quite work right, but how about if we try it in space? So he said, call up these other folks that actually see 2 other members of the team here today. Bob Silverberg is here in the audience, and Ray Weiss has come down from MIT to join us. And we quickly grew the team after this, but at any rate, this was 1974. So this was when we were all quite a lot younger, and we didn't know that it couldn't be done. So let me show you what we then did. Next chart will show you a little bit about the history. So in 1976, NASA headquarters decided they would choose a mission definition science team, and they chose members from all 3 of those proposals about the cosmic background radiation. 4 members from our original team and 2 members, one from JPL and one from Berkeley. And Nancy Bogus, who isn't here but sends her best wishes, was, I think, the person who most strongly advocated our project. There were, of course, committee meetings that said we should do this, but she was the person here at headquarters who insisted that even though this was difficult, it was very important. And so would we please start a study? So we did. In 1979, it was decided we would build this in-house at Goddard. And this is a point to thank the management as well as the engineering teams of those days, because it was recognized that there was no way you could buy a contract that would, say, build something that's 1,000 times better than anybody's ever done before. And by the way, we don't quite know how to do it yet. So in 1982, we were approved to construct it, and then, as Ed said, in 1986, the Challenger said we had to redesign everything. We had to lose 5,000 pounds of many things, but our engineering team accomplished that, and in November 18th of '89, it was launched. So our next chart shows you what we got. well, sorry, shows you some of the people that worked on this. Pat Thaddeus was the postdoctoral advisor I had in '74. And these are initial team members. I've underlined the names of the science team members, but wanted to include where I could pictures of their spouses, because this was very much of an all-consuming kind of project, and our team members spent a lot of time, a lot of overtime, a lot of dream time, a lot of every kind of time thinking about how to make this incredibly difficult project come out. So next chart will show you some of the rest of us as we grew more people. Chuck Bennett came. Nancy Bogus actually moved eventually from headquarters to Goddard to become my deputy. Ed Cheng, Ellie Dweck, Tom Kelsall, who's here, joined us. Phil Lubin from UC Santa Barbara. I think some more chart. Next chart. More of us. A lot of the people, by the way, on this team came by way of studying with Dave Wilkinson, who died a few years ago, and we're just finishing his biography. Anyway, Bob Silverberg is here with us as well today, and Harvey Mosley. So our science team grew to, I think, 18 people altogether. Next chart, I want to show you some of the people that actually made the incredibly difficult things happen. Project manager Roger Matson, I want to especially point out, is in the yellowish sweater there in the middle row. He was our project manager while we were trying to figure out not only how to launch it, but how to rebuild it to get it onto a different rocket. On our next chart, we have the other half of the engineering leadership team, and Dennis McCarthy in the back with a white shirt and tie. Was deputy project manager. He, I believe, is the man who actually found out how we were going to do this conversion to a Delta rocket configuration, and had, I think, attracted a certain degree of unwelcome attention from people who were concerned that he was looking into foreign launch vehicles, which would have been kind of embarrassing for us at the time, but it got attention. So it was determined by these people that not only could we rebuild the observatory, but we could rebuild it quite quickly. And we offered, I think, 2.5 years, or maybe, and we just about accomplished that. We went to being ahead of the queue, and these people were able to use that position to complete the project very fast. It was a miraculous accomplishment. So my particular thanks, let's see, where is he? Mike Roberto, who is my systems engineer for the FIRAS instrument. I guess he was on the previous picture. But anyway, many of our early members are here. So on our next chart, I have a picture of the thing that we built. It's still up there. It's in orbit around about 900 kilometers up in a polar orbit, and still spinning as far as I can tell. We don't use it anymore, but it's still available for communications practice. So on the next one, I want to show you what it was that we did with it. Here is my thesis project grown up on steroids, perhaps. This is to measure the color of the Big Bang radiation. And what we have that's special here is the Big Bang simulator, which in the top left is called the movable black calibrator. That emits radiation exactly the same way that we think the Big Bang radiation would look to us. So when we stuck that calibrator in the aperture and we got the same signal that we got from the sky, we knew we had demonstrated the Big Bang theory. So the next chart shows you what we saw. This is the chart that drew the standing ovation at, okay, next chart please. That drew the standing ovation that Ed mentioned. And I must say I was amazed when people cheered, because I knew this was the right answer. But everybody didn't know this was the right answer. There had been a lot of bad measurements and a lot of bad theories to explain the bad measurements, and it meant a lot more to people than I had realized. So it took me a while to cool off after I received this standing ovation and to say, okay, the next chart and so forth. But it was pretty important. So now on the next chart, I have a diagram of the thing that made a map of the cosmic background radiation to see if it was equally bright in every direction. So the